Right. You see, the word MED represents metric, but don't take it light. This metric is not a normal metric value. Even though it is metric, I agree with the word metric, but still people won't agree. Because MED actually means multi-exit discriminator. You don't find that word anywhere here, but that is what it is. MED. But I'm convinced with metric for MED. Why? It acts as a metric. See, when will we use metric? When we use multiple paths. Listen carefully. My question was, when will we use metric? When we have multiple paths to compare which one is better and to pick which one is better than the other, we compare the metric, isn't it? We compare the metric of both the paths. The path with lower metric is the preferred route. Am I right? OSPF metric, EIGRP metric, RIP metric. What does it mean? The value which says how much is this path preferred. If the path has got low metric, so repeat again. Yeah, in OSPF, metric of OSPF is cost. Metric of RIP is hop count. Metric of EIGRP is composite value. Bandwidth plus sum of delay. Now, when we have multiple paths, we use that metric to say this path is better than the other because this path's metric is lower. So metric only helps to pick one path and ignore the other one. Likewise, listen carefully, you need to wake up this place. You have multi-exit. See, metric is significant only if you have two paths, same way. Only when you have multiple exit, this metric is useful. Otherwise, it is not useful. In our topology here, the metric is not useful. Why? In this topology here, the metric is not useful. If you configure metric, it is useless. Enduku? Why? Why it is not useful? Because you don't have multi-exit. You may say, hey, this looks like a multi-exit. One exit, two exit. No, this is dual homing. Sorry, this is multi-homing. We want multi-exit, meaning we want something like this. Like this. Now, if you see this router, this has got multiple exit to the same autonomous system. The above neighbor, this one and this one, is of same autonomous system. You don't have multi-exit here. This is different autonomous system. This is different autonomous system. This is yeah, correct. You see, if this one is one single autonomous system, let's say this is autonomous system, BGP 30, then MED can work. I can put MED 10 here, MED 20 here, so that all will go this way. Lower is preferred. All will go via the path MED 10. But it's two different autonomous systems. If you set 10 here, 20 here, that is of no use. Metric should come from the same autonomous system. When this advertises these networks, it will say I am autonomous system 20 saying metric 10. This guy will say I am autonomous system 30 saying metric 20. What is the use? The metric will not be advertised to this router, will not be advertised. It is only between here. So, you need different topology. Like what? Like what you see in this presentation. Like this. You see, two connections are connected to the same autonomous system from this autonomous system. Now, let's go back and read this, then we'll go there. MED is used when multi-path exists between two autonomous systems. Just two autonomous systems. But in this case, you don't have two autonomous systems. You got three autonomous systems. Multi-exit is there, 1 and 2, but how many autonomous systems? 3. Not possible. So, that topology we cannot use. We'll use another topology later. Now let us learn first. Multi-exit discriminator is used when multiple paths exist between two autonomous systems. Lower metric is preferred. The default is 0 in Cisco. And the metric is an optional non-transitive attribute. All right, we learned in the beginning different type of attributes. This is one of the optional, at the same time non-transitive. It will not be sent, not found. At least 0 should be there. If no metric, no valid update. The update will not be sent to anyone. Usually, MED is shared only between two autonomous systems. Please pay attention to this line. MED is shared only between two autonomous systems that have got multiple eBGP connections with each other. How much autonomous system? Only two. How many connections? Multiple connections. What type of connection? eBGP connection. Yep. So it is MED. MED is considered as metric of BGP, but you remember, even though it is considered as a metric of BGP, this will not be used if you don't have multi-exit. This will not be used if there is no tie between that above 6 attributes. You remember, we have a list of attributes. In the previous chapter we learned. Now here we saw the list. You see, even the BGP calls MED as a metric, but for the MED to take effect, there should be tie in this above 5 plus 1, no, value next of 0 that there should be tie in this above 0 to 5 attributes. If not, this is not going to be useful. Again, very clearly written, exchanged only between the autonomous system, meaning it is exchanged between the eBGP routers. My friend, if you would have configured local preference, it will not come here. If one of the path is shorter than the other, it won't come here. Understand this very well. So, because of the word metric of BGP, you should not get misguided. You should not get misguided. MED is considered as the metric of BGP. It means that it doesn't mean that if I change the metric, immediately the path will be changed. No. That won't happen. All the routers that are advertised to an eBGP neighbor are set to the value specified using this command. So we put this command and tell what MED to advertise to the eBGP neighbor. For example, you see here, on this router, we have used the route map and matched this 25 and put MED 200. And we have matched 26 and 24. Sorry, we have matched 24 and put 200. Why, we don't want anyone to come this way. Why you don't want them to come this way? Because 24 is down. If they come this way, it will be consuming all your bandwidth, CPU, resource. You don't like that. So you have given big number for 24 in this route. And for the other two, you have given 100. On router B, you like 25 and 26 to go a upper path. That's why you gave 100 here. Here you have given 200 because for 25 and 26, it should not come this way. It should go only via the upper path, lower metric. Only for 24, it will come this way. Did you understand this? While advertising the network, I am going to advertise this value also to the neighbor. In the other attributes like weight and local preference, you are not advertising anything to the eBGP neighbor. When the route comes, you just append the attribute local preference and send to all eBGP router. You just append the weight and use it locally. This is the only attribute that is sent to the other router in the other autonomous system. Like this. You see, you have written, this is the configuration on router A. This is here on router A. Pay attention, very close attention on router A. 25, 26 should have 100. 24 should have 200. Now you see, 25, 26. You have set 100. For the other networks, you have put 200. What is the other network? The other only network is which one? 24. So 24, even though you don't have an access list, it will get 200. Did you understand? See this, sir. How many networks A is advertising? How many network A is advertising? Bala, this is not your question, my dear. Sir, how many network we are advertising? 3. In this, which two are preferred on router A? 25 and 26. Now, we write access list for 25 and 26. We call that access list under the route map, and we are setting 100 for all other network. Which is the only other network left? 24. It is going to assign 200. 24, even though we have not written an access list, that's the only other network other than 25 and 26. Did you understand this? Now, we are taking this route map and binding to the neighbor, which is an eBGP, see 28.1, this guy, X. So I'm telling router A, whenever you speak to 28.1, you need to do what the route map says. See, this is out. You're advertising to the eBGP neighbor. Out. You're giving eBGP neighbor. You're not taking. You're giving. See the arrow mark there. The networks belong to you. You're giving to X router. Is this clear? Is this clear why it is out? Oh, 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 oh. Huh? All right. You see, first you will finish all these configuration, and then you will go out of BGP. That's why they put exclamatory mark. You will write this access list, you will write this route map, then you will go to BGP once again, add this line. So I'm going to do this left. Okay. So you see, we have two autonomous system, and you can see multi-exit. I'm going to quickly configure IP address and OSPF on each autonomous system. I'll call the left-hand side as AS1000. The color is too dark. And AS2000. Let us use a notepad to finish the basic configuration with BGP. So when I say basic, don't think that, I'm just going to put only IP address. No. Enable config the interface loopback 0 IP address. This is for router 1 I'm doing. And then interface Ethernet 00 10 12 01 or 16. And then interface Ethernet 01. And then let us do OSPF IP OSPF 1 area 0. And now I'm going to paste this on router 1. Did I give the host name? No. Next is, shall we do router 2? Yes. E00 is 2 here, and E01 is, what is E01 of router 2? Very good. Now, I'd like to put this on router 2. But before that, sorry, I want to do something. I don't want to say OSPF on this because it's a WAN facing interface, right? Hello. We don't want to run OSPF on WAN facing interface. Now, router 3. This is 100. And now, router 4. And this is going to be what? 45. And this is going to be what? And now router 6, let's finish. Zero. Huh? Z. Z, Z, not G. Mm. But you are a hero. It's okay if you don't know how to say zero. You are in US. So don't care. Mm. Okay, router 6 is over. Now router 5. And the router 5 E00 is 45. And correct? Now I'll paste this in router. Now we are going to do the actual BGP configuration. Please pay attention. Now I'm starting from router 1. Router BGP 1000. Sorry. Router BGP 1000. Neighbor is 10.12.0.2. Remote AS 1000. Neighbor is 10.13.0.3. Remote AS 1000. You agree? And the network that we need to advertise here is yeah. Now I'm going to now copy this configuration to a notepad and do alteration. Shall I do that? Now I'm going to do this for router 5. Let's finish 5. Okay, no problem. 2 is also good. Same 1000. No? So router 2 has got network 2.2.2.2 and 10.12.0.1 and 10.13.0.3. This is same. One more thing is full mesh I'm making. Yeah, no, full mesh I'm doing. It is okay. It will do. IBGP will work. Now, next stop self. Sir, do you follow me? Because Bala was not present in this chapters. Don't worry, my dear. That's what I was telling. You don't worry about that. No, you don't need to worry about that now. I'll repeat for you BGP from the beginning. That time you will know. Now, we also have one eBGP, which is neighbor 200.24.24.4, isn't it? That is all. This goes on router 2. Let us finish router 3. Ten dot 13 10 dot 12.0.2 10.13.0.1 and then and then 36 dot okay, I think I made a mistake here. I should have said 200. I gave 100. Anyway, we'll check that. I'll go to router 2 and check what I have done. You see, I put 100 instead of 200. Do you see that? So I'll remove this line. Okay, now let us do this. Sare, where are you? Are you in this earth or in the galaxy? Ah, ah. Sir, let us ask our sir. All right, so router 3 is also ready. Let's quickly go to router 6 and finish the config. This is autonomous system 2000. Neighbors are 10.65.0.5, and then 10.45.0.4. And then this one is dot 3. And this is 1000. This one is 2000. This one is 2000. Now this will go on router 6. After this, let us finish router 4. 4 and 4 and 4 and 4. 10.45.0.5, 5, and 65.4. This is same. Am I right? Yes. This will be 6. From 4, I am forming neighbor with 6. And this will be this will go on router. Now let us finish this last router. There's no need for next upself here, so I cut this off. I cut this off. Only 2 neighbor. And the router 5, this is going to be 45.4, and this is going to be 65.6. That is all. What a mistake I have done, you see. Okay, no, just the host name only. Okay, that's right to me. I need to just add one more line, host name. Yeah, I'll check. Right. So on R6, there is no problem actually. Only the host name I forgot to change it. See, the neighbor has come successful. One more neighbor also will come with 4. Show IP BGP summary. See, this is in this address. And it will come. It will come. This is a from neighbor, a configured name. IPGP, what you are saying, never, sir? I don't understand. Here it is, router 4. Wait, yes, wait, yes. Okay, this is the problem. On R6, there is an issue. 10 dot 10.65.0.6, correct only. Okay, and for here I need to ping this. Okay, it is pinging. Okay, I made a wrong configuration. Show one section router. This should have neighbor with 5. Instead, I should put 5 here. That's why you should not do when you're hungry. You should not do lab when you're hungry. And then the other neighbor is this one should be dot 6. That's all. Problem solved. Okay. So now what I'm expecting is, let us go to router 1. Show IPBGP. We are advertising this locally. Likewise on R2, show IP route. Show IPBGP. We are advertising this 2222 locally. In router 3, we are advertising show IPBGP. 333 locally. Pay attention, pay attention, pay attention. From router 5, if you check, to go to 123, what is the next stop used? 4. All are going via router 2. That is the meaning, okay? All are going via router 2, which I don't like. So what I'll do is, I'll go to router 2 and set MED. Router, no 1 minute. Last minute, you cannot ask this question. What happened? Tell me. What can you? If it goes to router 4, where it will go? It will go to router 2 only. Correct? I don't know what Bala is thinking. Listen, Bala, these 3 networks, if you go via router 4, how it is going? Via router 2 only. For 333, 222, 111. Okay, now, so I go to router 2 and I'm going to put this command, not this command, we are not this one. Default metric. You understand? We are not going to use any route map, anything in today's class. We'll do those things in next class. So for all network, I don't want it to go via router 2. I want it to go via router 3. So I can do changes in router 2 so that it will go via router 3. How? Default metric. I'm going to say 10. What is the default? 0. Router 3 is advertising with 0. Router 2 is advertising with 10. You understand? So now if you go to R5, you will see changes. Look at this. 111, it started going via, wait some time, still changing impact. Show IP route BGP. Still is going via router 4, wait some time. Go to router 4. Show IP BGP. Still it has not learned. It should learn metric. Clear IPBGP starts up. R2 will advertise to R4. Still, I'm not learning MED. On router 4, I'm not learning MED. Okay, I'll do one thing. I'll do some advanced configuration in router 2. I'll use route map. No, it's okay. I'll use route map. Let's not get into other research now because it's late now. We'll do those research later. I removed this default command. Instead, what I'm going to do, I'm going to write an access list, IP access or access list 10 or permit any for all network I'm seeing. And then I'm saying route map any match IP match address match IP address 10. If that match happens, set metric 10. And I'm going to use this router BGP 1000 neighbor 200.24.24.4 route map any out. So when I'm advertising this network out, I'm going to put metric 10 clear IPBGP star sub. Now if you go, definitely you will see that. Router 4, you see the 10 got added in MED. I configured on router 2. The impact is seen in router 4. And you go to router 5 and check now. It goes via router 6. Earlier it was going via router 4. Earlier it was going via router 4. Now it is going via router 6. Did you understand, sir?